Hiya, Michael here with a video about electrolytic rust removal, and I'm focusing on the science. Now this is quite a long video, so if it's too long and you didn't watch, well, I'll give you the information, the least that you need to know straight away. So there are 4 things you need to know. First of all, the electrolyte contains H+ and OH- ions. So the water in the bath is ionised. The rusty workpiece is the cathode. It's connected to the negative terminal. And hydrogen is produced at the cathode. Now then, the red rust is reduced by the hydrogen. What that means is that the hydrogen steals the oxygen from the iron oxides and it forms a black iron oxide. And that can be easily removed by abrasion to leave a rust-free surface. So that is the information. What follows is how it works. So you will all have seen something like this, bath full of water with washing soda in it. The purpose of the washing soda is to ionise the water. And then you've got your rusty workpiece, which is connected to the negative terminal. It's the cathode, and you've got usually an iron anode. And you'll notice that throughout the operation, the iron anode goes rusty and the workpiece loses its rust. So that's the basic idea behind it. So now let's look at the science. And to understand the science, it will help you if you know the anode, the positive terminal, liberates oxygen. The cathode, the negative terminal, liberates hydrogen. And this is quite important. Iron can exist in 2 oxidation states, and they're called iron 2 and iron 3. Now iron is a transition metal, and the electron shells get a little bit complex, and that's why it can have these 2 oxidation states, or if you prefer to think of it, 2 valencies. So keep that in mind. Now, rust is a mixture, and it's an ill-defined mixture. What I mean by that is it doesn't have a distinct chemical formula. So rust is a mixture of mainly iron oxides. There are other bits, but I'm not going to talk about them. Now there's iron 2 oxide, which has got a formula FeO, and that's black. There's iron 3 oxide, which has got the formula Fe2O3, and that's a kind of reddish brown colour. And then there's a kind of hybrid iron 2,3 oxide, which has got the chemical formula Fe3O4, and that's black, and interestingly it's magnetic. So although rust is a mixture, each of the constituents of the rust here have a distinct chemical formula, and we'll want to know that a bit later. So now let's talk about what happens in the electrolyte, at the anode, not very interesting, and at the cathode. That's where the magic takes place. Now in the electrolytes, an ionic solid, usually we use washing soda, is added to the water and it dissolves and it forms ions, but they don't take part in the rust removal. But what they do is they cause the water to form H plus ions and OH minus ions. And it's these ions that do the work, as we'll see in a moment. So here's a schematic diagram. Let's look at the anode first of all. That's got a positive charge, so it attracts the OH minus ions to it. As the OH minus ions touch the anode, they get discharged and it gives off oxygen, and it's this oxygen that rusts an iron anode. And you will have noticed that you get bubbles of oxygen given off. Now, at the cathode, which has got the negative charge, that attracts the H plus ions. So they touch the cathode, they get neutralised, and they form the hydrogen gas. And it's the hydrogen that is given off that changes the rust into iron 2 oxide, which, if you remember, has got the formula FeO. Okay, just for completeness, this is what happens at the anode. The OH minus ions get neutralised, form oxygen and water, and the oxygen is the gas that bubbles off and rusts an iron anode, and this is how it works. 4 hydroxyl, that is OH minus ions, come along, they lose their 4 electrons and they rearrange themselves to give you 2 molecules of water and 1 molecule of oxygen. It's a similar story at the cathode. So this is where the exciting stuff takes place. And the H plus ions are neutralised. Hydrogen, H2, is given off and it reacts with the rust. And this is how it works. 2 H plus ions get attracted to the cathode. They gain 2 electrons and it forms a molecule of hydrogen. Good. We're nearly there now. So what we're going to do is have a look at how the hydrogen reacts with the rust. Now, do you remember we said that rust is a mixture of oxides? Well, let's see what happens to each of the individual oxides. FeO. That, if you remember, is iron 2 oxide. Well, there's no reaction, so we finish up with what we started with, FeO. Fe2O3, that, if you remember, is the iron 3 oxide. Well, the hydrogen reduces it to 2FeO plus H2O. So we finish with FeO. And Fe3O4, that's the black iron 2,3 oxide. If you remember, the hydrogen reduces it to 3 FeO plus a molecule of water. So all the rust, it starts off at this mixture, but it finishes up, all of it is FeO, FeO, FeO. So like we say here, all the rust is converted to FeO. Right, let's have a look at a diagram of that now. So I'm only going to look at Fe2O3, and this is the key key idea. If you get this, you've got more or less everything. So we start off with Fe2O3. Remember, that's iron 3 oxide. Add some hydrogen, H2, and it goes to 2 lots of FeO plus a molecule of water. And FeO, if you remember, is iron 2 oxide. Now then, how does all that work? If we think about valency rather than oxidation states. So here we've got Fe2O3. So the iron here has got a valency of 3. So we've got 1, 2, 3. And here this has got a valency of 1, 2, 3. So altogether I've got 6. And oxygen always has a valency of 2. So can you see each of the oxygen atoms shares 2 valence electrons. It's sharing electrons because it's covalent. Now then, this oxygen is very strongly bound to the iron atom. Similarly, this oxygen atom is very strongly bound to the iron atom. But this one, it's not so strongly bonded because it's sharing its bond between 2 atoms. So along comes a molecule of hydrogen. It can't take this oxygen, it can't take this oxygen, but it can take that oxygen. So what we finish up with is FeO, very strong, very stable bond there, same there, and a molecule of water. So, I should point out, this is purely schematic. It's not what the molecules look like. But the important thing to realise is that you start off with iron 3 oxide and you finish up with iron 2 oxide plus water. So, to summarise, the electrolyte contains H plus ions and OH minus ions. The rusty workpiece is the cathode, and hydrogen is produced at the cathode. And the reason for that is because the H plus ions are attracted to the cathode, which is negative. They get neutralised and produce hydrogen gas. And this is the absolute key. The hydrogen reduces all the red rust to black iron oxide. And there's a picture here. You can see the red rusty bit here. I dipped that bit in the electrolyte and made it work, and you can see it's black. So it's gone from red rust to black iron oxide. Well, I hope that was a good use of about 14 minutes of your time. I hope you enjoyed it, and knowledge is power. So now you know how to do it, but you also know how it works. How good is that? Okay, Michael signing off now. Bye.